So for this problem, it says find the requested function value of theta. And of course, here for question number one, they give us kind of some information, some initial context here that the cosine of theta is 1/4, and we're supposed to find the cosecant. Well, first off, based off the information they gave us right here, we could draw a triangle. Since we know the cosine of this mystery angle, we know the, of course there I'll put theta, we know the adjacent over the hypotenuse. So this must be the adjacent and this must be the hypotenuse. Of course we're supposed to find the cosecant, and remember cosecant is actually the reciprocal of sine, and so it's the hypotenuse over the opposite. Because sine is opposite over hypotenuse, so this must be hypotenuse over opposite. So we really need this opposite side here. I'll call it x. So now we can just do good old Pythagorean theorem. So a square plus b square equals the c square. And that's just 1. 4 squared is 16. If we solve for x, we get that x squared is 15, but we just need to square root both sides. And so we get x equals the square root of 15. So that would be this opposite side, which is what we need. And our goal is just to find the hypotenuse over the opposite. And so it looks like here, I'll write that over here. So we got the cosecant, which is what we want. And it's the hypotenuse over the opposite, and we found the opposite now. We always had the hypotenuse. So it's 4 over root 15. And actually 4 over root 15, we want to rationalize that. I mean, I guess technically we don't have to, but it's actually always good to rationalize the denominator. And so to rationalize the denominator, we just multiply the denominator by that root again, multiply top and bottom by that root again. And so this top just becomes 4 root 15, and then root 15 times root 15 is just regular root 15. It takes 2 to make a thing go right there. And that's our answer. The cosecant of theta is 4 root 15 over 15. Notice we didn't even care what the angle is. It's not asking us for the value of theta. It doesn't want us to find the angle. We just need to use the information to find the value of the cosecant of theta. This next question, and I'll just kind of separate it and use a different color here. This next question is very similar. This time we have some different information. This time we know that the tangent of some angle, again we don't even care what the angle is, we know the tangent of it is 5 over 2. And we're supposed to find the sine of that angle. Well, if the tangent of theta is just opposite over adjacent. And so based on this information I can draw a triangle. A right triangle, and if here's my new mystery angle, the opposite is 5 and the adjacent is 2. We need to find the sine of this angle. Notice again, we still don't even care what the angle is, and so the sine is what, opposite over hypotenuse. So it looks like all we need is the hypotenuse. We already know the opposite, so it's going to be 5 over something. You know, we just need to figure out what that something is. So let's just do Pythagorean theorem. A square plus b square equals c square, and I'll just call this c square. And so what is that, 4? That's 25. If we add those together, we get 29. And of course that's what c square is, so we square root both sides to get that c is equal to the square root of 29. So there's the hypotenuse. We found the hypotenuse. I'll just go ahead and put it right there for the hypotenuse. And actually, there we go. I just need to put it as 5 over square root of 29. And again, really, we should probably rationalize that. So 5 over square root of 29, what we can do is just multiply top and bottom by square root of 29. And that makes it so the denominator is no longer a crazy square root. It would just be normal 29. And so there we go. We have rationalized it, and so the sine of that angle is just 5 root 29 over 29.